Hey guys, so for lack of time and due to the fire alarm going off and because of meetings, I'm just going to talk through my key. So for the first three, you had to put your log form into exponential form. So the base of your log is the base of your exponent. You're going to raise that base to whatever your log was equal to, and then set it equal to whatever you were taking the log of, which was 16. Same thing for the other two. For 4 through 6, you're taking your exponential form and putting it into log form. So the base of your log, base of your exponent, base of your log. Taking the log of whatever your exponential was equal to, and you're setting it equal to whatever your exponent was equal to. You did the same for 5 and 6. For 7, 8, and 9, you were evaluating. Now, you could sit here and put all three of them into your calculator. And I kind of already wrote it as if you were going to put it in the calculator. Or you could do it how we did in the actual lesson, where you have log base 5 of 125, and you put any random letter right here or variable right here to represent the answer. So let's say it was x. Then you would change that log form into exponential form. So that would be 5 raised to the x equals 125. So you're asking yourselves, how many times would we have to multiply 5 to itself to get to 125? Well, 5 times 5 gives us 25. So that doesn't give us to 125 yet. Times 5 again does get us to that 125. So we multiplied 5 to itself 3 times. So our answer is 3. Same thing kind of works with 8 and 9, except for you would have to be using your log properties or your log rules. For this one, if you put an x in that blank spot and you change it to your exponential form, obviously x would be negative 3. For 9 on my paper, I already switched it to my log form. Remember in this one, your base of your log, if it's not written, is 10. So for number 10, you had to use your formulas for compound interest. Those formulas are A equals P times 1 plus R divided by N raised to the N times T power. You also need to know your A equals P times E raised to the RT. This is your continuous one. This is your periodic one. So when we're asked our annually, semi-annually, quarterly, daily, I think that was all of the ones that we actually did. You're using the longer one, the periodic formula. When it actually says continuous, that is when you're using the PERT formula, that second one, for continuous interest. So you were plugging it in according to our word problem. Our percentage is 2%. So our R is going to be 0.02. Our P is our initial amount, so that was our 5,000. Our T is how long that investment is in the account, so that is my 30 years. And then my N changes depending on the problem. So for annually, my N was 1. Semi-annually, it was 2. And quarterly, it was 4. Make sure if you're using the old calculators tomorrow, you put parentheses around your exponent. And then continuous is kind of the same thing. It's the same at P, R, and T. You just plug it into your calculator. 11 is not compounded interest. 11 is creating your exponential form or formula. Y equals A times 1 plus or minus R raised to your x. That is what you are using. Your a is your initial amount, your r is your rate of change, and your x is how long it's been, time. So in this problem, our a is $15,000. Our r is our percent, which was 4%. So we plug those in. Remember to change your percent to a decimal. And then we were asked, what would the sale price be in 2019? So between 2011, 2018, or 2019, there was 8 years, so our x was 8. For number 12, we wanted our base, which was e, of our exponent to be by itself, so we divided by 5. When we did this, we have a e raised to the x plus 3 equals 8. We create our natural log. The reason why we're doing a natural log and not a log is because our base is e. The imaginary e is right there. So base of my exponent, base of my natural log, taking the natural log of my 8 and making it equal to my x plus 3. To simplify, I've got natural log 8 minus 3, and I put it into my calculator, and it is negative 0.92. Same thing with 13. Only difference is that there was no e, so we do not use the natural log. 14, we needed to condense our logs first, and then we could set the parentheses or our values equal to each other. So we had subtraction, so our subtraction changed to division. And then we had x minus 5 divided by 2x equals 19. We wanted our 2x to move to the other side, so we multiplied both sides to get 38x on the right side and x minus 5 on the left. Move my x over. When I moved my x over, I got negative 5 equals 37x. And I simplified, so x equals negative 5 divided by 37. It's very similar for number 15. Okay. So on the other side, we have our transformations. So transformation for the first one, we've got a negative 1 on the inside. We're on the inside, we're affecting the x's, so we're going the opposite of what it says. We've got right 1, up 5. 15 and 18 gets into reflecting. So if it's on the outside of our exponent, it's going to be reflecting over the x-axis. If we're on the inside, it's reflecting over the y-axis. And don't forget, when you're asked, you do have this negative 2 outside, so we are shifting down 2. 19, we were given an exponential equation. I first like to create my graph. Once I create my graph on my paper, then I can look at all of my key features. So according to my graph, my domain is going to keep going all the way to the left forever and ever and ever, so negative infinity, all the way to the right forever and ever and ever to positive infinity. Our range, our smallest y value is going to be found at 1 because that's where our asymptote is, but it's going to keep going up forever and ever and ever. So our range is 1 to positive infinity. Make sure your domain and range is always in least to greatest form or ascending order. For your asymptotes, this again is an exponential equation. All your exponential equations have asymptotes that are horizontal. So there was a horizontal line where that line did not cross. And that line was at 1. Y is 1. Yes, you need to put y is 1 on your test. Your transformations was right 2, up 1. got a negative 2 on the inside, so that's our right 2. Plus 1 is on the outside. 20, similar thing. Went on ahead and graphed it. This was our log function, so we're going to have a vertical asymptote, which is right there. That vertical asymptote is at negative 1, so that's why the answer for asymptote is a x equals negative 1. Your domain, your x values, are not going to hit negative 1, but it's going to get really close. So we're going to go negative 1 all the way to the right forever and ever and ever. Your range is going to keep going down forever and ever and ever, so we're going to have negative infinity all the way to positive infinity because it keeps going up very slowly, but it keeps going up. Transformations, left 1 because that plus 1 on the inside, and up 1 because we have plus 1 on the outside. So for 21, 22, and 23, you needed to condense it. So we have our 2 as a coefficient, so our 2 goes back into the exponent. So we would have 6 raised to the 2, and this gives us 36. That is where the 36 is coming from in the answer. Then we have addition. Addition turns into multiplication when we're condensing our logs. So we have that 36 times x, so there's our numerator. Then we have subtraction. We also have another coefficient that becomes a exponent. Subtraction turns into division, and there we get our answer. Very similar with 22 and 23. Make sure you get rid of all of the coefficients. All of the coefficients should turn into exponents. 24, you're just expanding. So there's multiplication in between here, so it becomes addition. The 3, instead of staying in the exponent of x, it moves out front of that one log. Same thing with a y squared. Instead of a 2 in the exponent, it moves out in front. Similar with 25. And similar with 26.